Wait.
Alright, this next section is basically the same thing we did in the last section, just also introducing imaginary zeros as well. Okay? So we're going to go through a lot of the same processes as the last section. Okay? We just might get imaginary answers.
Grade those tests.
Yes.
You literally sent you an email.
Yeah, I sent. Everybody should have gotten an email last night with your updated overall grade. Okay? Because remember, on eSchool Plus, it shows all your individual assignments, but it won't let me change how the final grade is calculated. Okay, so the final grade, since we're doing 10% homework, 10% quizzes, 55% tests, and 25% final exam, your final grade is calculated literally. So I sent everybody an email last night. Overall grade is right now. Okay, did everybody get those? So, okay, real quick, just going to review these three ideas. Okay, the first, the factorization theorem for polynomials. Okay, this just that any polynomial can be written as a set of factors being multiplied together. Right? So, any polynomial can be written like this. Okay, we'll have some coefficient out front, and then we have factors that show us each of the zeros. Right, so x minus a, x minus b. Right, just listing all of the factors out like that. Right, factors. Right, these would be the same as all of the zeros. Right. Now, it is possible that we have irrational numbers here. It's possible that we have imaginary numbers here. Okay. So, for example, if I tell you that we have some polynomial with zeros at 4, 7i, and 3 plus the square root of 2. First of all, and I guess this comes into play in the next two ideas as well. First of all, what's the minimum number of zeros that this polynomial would have to have? Okay, we talked about this idea a little bit yesterday.
Oh, 5.
It'll be 5. Why will it be 5? Why does this polynomial that has these 3 zeros have to have 5 zeros? What's that? For all of them? Right. These ones have to come in conjugate pairs, right? We talked about that a little bit yesterday. So if 7i is a 0, negative 7i is also a 0. If 3 plus the square root of 2 is a 0, 3 minus the square root of 2 is also a 0. So if I wanted to write this polynomial out, okay, I'm just going to list these factors. So I would say x minus 4, x minus 7i, and also x plus 7i. Then for these, x minus 3 plus the square root of 2. When we have something like this, okay, that has more than one number or more than one term as a 0, we want to put it in parentheses when we're writing out the factor. Then the last one would be x minus 3 minus the square root of 2. Okay, so I can write any polynomial as a list of its factors being multiplied together. Okay? Whether those are real numbers, imaginary numbers, rational, irrational, okay, any polynomial can be written in this form. Okay? The number of zeros theorem just says that the degree of a polynomial So again, zeros doesn't necessarily mean where we cross the x-axis. Okay, we're talking about solutions. Right? They could be imaginary. They could be, well, I guess the only way they wouldn't cross the x-axis is if they're imaginary. Right? So if we're looking at this polynomial, we came up with 5 solutions, right? But it would only actually cross the x-axis at 3 places, at the real numbers. It doesn't cross the x-axis at the imaginary numbers. Okay. So if we are given a 4th degree polynomial, we know we're going to have solutions. If we're given a 17th degree polynomial, we are going to have 17 solutions. Now, we also have to remember that some of those can show up multiple times. Right? We could have a factor of x minus 1 to the 3rd power. Right? That same 0 would be showing up 3 times. Okay? But we would still count that as 3 zeros when we're thinking about the degree of a polynomial has exactly that many zeros. Okay? We okay with that one? Okay, and then the last one we just kind of talked about already, the conjugate pairs theorem. Right? Any irrational or imaginary solutions come in conjugate pairs. Okay, so if 7i is a 0, negative 7i is a 0. If 3 plus the square root of 2 is a 0, 3 minus the square root of 2 is a 0. Okay. So, similar to what we did up here, the first example just says, find the polynomial in standard form with real coefficients having a degree of 3, a leading coefficient of 2, and zeros of 5, and negative 3i. Okay? So I'm going to go ahead and scroll down. Need a little bit of room for this. So how would I start this problem? Write this polynomial. I'm given 2 zeros, but it tells me I have a degree of 3 and a leading coefficient of 2. So how am I going to start this? So I guess first it tells me I have a degree of 3, right? But it only tells me 2 of the zeros. What would the third 0 have to be? What is it? Positive 3i, right? All irrational and imaginary zeros come in conjugate pairs. So if negative 3i is a 0, positive 3i will also have to be a 0. Right? So it tells me my leading coefficient is 2. So I can go ahead and throw that out front. And now I just want to write my zeros as factors. So how do I do that? X minus 5. X plus 3i. And x minus 3i. Now, it does say in standard form. So standard form means we want to multiply everything out. Okay? If it didn't say standard form, we could just leave it like this. Right? This would be an acceptable answer. But since it says standard form, we need to multiply this out. Whenever we have imaginary zeros, probably a good idea to start first. Okay? So I'm going to leave the 2 times x minus 5 out here. And then I'm going to multiply these 2 together. So we're just FOILing, right? X times x squared, x times negative.
I squared just negative 1.
I squared is equal to negative 1. Okay, so that's a key thing that we need to remember. Right? I squared is equal to negative 1. So here, I'm going to have minus 9 times negative 1. Well, that would just be plus 9. Right? right? Negative 9 times negative 1 would be plus 9. So this just becomes x minus 5 times x squared plus 9. So then from here, we could either distribute the 2 through first, or we could multiply the two binomials and then distribute the 2. Okay, doesn't really matter what order we do multiplication in. I'll distribute the 2 through first. So 2x minus 10 times x squared plus 9. And then we're FOILing. So 2x times x squared, 2x cubed, plus 18x minus 10x squared minus 90. So then, technically, to actually put it in standard form, we need to make sure the powers are in descending order. So I would just need to flip the 18x and the negative 10x squared. We okay with something like that? Okay, given the zeros, right, and a leading coefficient and a degree, we can list out our factors. And then if we want it in standard form, just multiply them all together. And if we have imaginary zeros, the key to simplifying is that I squared is equal to negative 1. Okay. Questions? All right, then I think the next two are a little bit easier. Okay, we're just solving for x on each of these. You guys think you can take a couple of minutes and solve for x on these? Or do you want to go through them together? Sure. So on the first one, it's already factored for us, right? So to solve for x, I'm just setting each individual factor equal to 0. So x plus 1 equals 0, x minus 2i equals 0, and x plus 2i equals 0. So when I solve those, I would get negative 1, positive 2i, and negative 2i. So hopefully some of these are a little bit of a review from either Algebra 2 or Pre-Calc. Okay, so let's take a minute or two here and see if you guys can solve B, C, and D here. The idea is whenever we have a negative, I can split that up, right? Like here, if I had the square root of negative 81, I can make that the square root of negative 1 times 81, and the square root of negative 1 is just I.
No.
I like my feelings. You should get it from the hospital.
Yeah, all right.
You are pretty good. I cut negative 5 plus or minus 3 out of 2. Why isn't there 3? 3. I get I'm so tired. It's not even right.
All right, did we get plus or minus 9i for b?
Yeah.
Okay, so the idea here, okay, the simplest way I think to solve it would be to bring the 81 over to the other side, take the square root. When I take the square root of a negative number, I can split that up. Okay, I can just make that the square root of negative 1 times whatever that number was. And then we just know the square root of negative 1 is equal to I. So in this case, 81 is a perfect square, so we just end up with plus or minus 9 times I. We could have actually done this using the quadratic formula too, right? Whenever we have a quadratic, you can use the quadratic formula. So that would have worked for B. Okay? For C, there's a couple of ways we could do this one as well. We could use the quadratic formula by add the 7 over to the, or I could complete the square. Right? This one's kind of set up to complete the square already, but we could use quadratic formula as well. Which one are you guys more comfortable with? Quadratic formula? Okay. So then we would have to add the 7 over and get everything on one side equal to 0. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So if we simplify that, 25 minus 28 would be negative 3, right, over 2. So then if I have a negative number inside the radical, 1 times the square root of 3, I'll just go ahead and write the square root of negative 1 as I. How about D? Did you guys get a chance to try D? What'd you do for D? I think this one factors, right? So if I factor by grouping, okay, look for a GCF in the first 2 terms. So that would be, I could take 2x squared out, right? And I would just be left with x plus 1. And then I could take 9 out of both of these. Oops. Sorry, not 2x squared, just x squared out. And I'd be left with 2x plus 1. And if I take a 9 out here, I'd be left with 2x plus 1. So then I would have x squared plus 9 times 2x plus 1. I can set each of these factors equal to 0 now. So x squared plus 9 equals 0, and 2x plus 1 equals 0. If I subtract the 9 over, take the square root. So this would become the square root of -1 times the square root of 9. Right? So this would just be I and plus or minus 3. So plus or minus 3i for this one. And then if I subtract the 1 over, divide by 2, we get -1/2. So for this third degree polynomial, we get our three answers are positive 3i, negative 3i, and -1/2. You okay with that one? Eh? Alright, so then the last two examples are just going to be exactly what we did yesterday. Really? Yes. Then we can double homework.
No.
So, these last two examples are exactly what we did yesterday. We just make it imaginary zeros, or imaginary answers as well. Okay, so what's the first step, okay, to solving something like this?
13.
Find all the possible zeros, right? So all the factors of 13 over all the factors of 1. So all the possible rational zeros. We'll have plus or minus 1 and 13. I guess I should write those in order. 1 and 13 over 1. So the only possible rational zeros are 1, plus or minus 1, and plus or minus 13. Now what? Graph it and find where one of those zeros are. So there's only 4 possibilities, right? Positive 1, negative 1, positive 13, negative 13. So where do we see a 0 if we graph that? At -1. So what do I do with -1 now? Synthetically divide that out. Right? So we'll have 1, -5, 7, and 13. 6, 14.
That was pretty good.
So now we end up with our depressed polynomial x squared minus 6x plus 13. Now what do I do? How? Math. Just math it. Quadratic formula is probably going to be our best bet. Right? What's that?
There's a way you clear the calculator and solve for it.
Yeah, I think there is a program in there somewhere. Okay, so let's see. 6 plus or minus, so we get 36 minus 52. So what is that? Negative 16 over 2. So the square root of negative 16 is just going to be plus or minus 4i, right? Over 2. So now I can split this up, simplify, and I can make this 6 over 2 plus or minus or I over 2. And then I can just do that division. So 3 plus or minus 2I. So my 3 answers are -1, and then 3 plus or minus 2I.
It actually matters.
Any questions on that one? All right, then we've got one more. You guys go ahead and try the last one on here.
Oh, this is our homework for the weekend?
Oh yeah, there's this. Sam, do the brains. 20 equals do.
Good.
You know, it's gonna get. Which one are we doing first? Sad. I'm pretty sure that factors. But I just don't. Yeah. Isn't that factor? What's that factor? What'd you get? Bro, she's a moonshine. Brady, I really don't want this really.
You got the 4 on the side. That would be by graphing, right?
Yeah, I mean, if just graphing the original equation, we can see it crosses both 2 and 4. So we're not graphing this one and seeing it crosses these two.
You did math wrong.
Did I do math wrong? Or did I do math wrong? Oh, yeah.
Yeah, did math wrong.
So what is the
Wait, what?
In the box.
Oh, in the box.
Honestly,
That's better.
Should.
But still one math prior. Jackson, is that just black coffee?
Yes.
Okay.
That's all I drink.
Alright, did we get 2, 4, and then 1 plus or minus I? So graphing it, we should see that 2 and 4 are both zeros, so I can synthetically divide both of those out. It's my depressed quadratic, and then using the quadratic formula, you should just get 1 plus or minus I. Any questions? Yeah, what's the
How did it take Mr. Allball?